14th. It's 5 o'clock. 14th, 5 o'clock. And we're still working on the Eureka Tool, but it needs cutters, right? The ratcheting pawl system and that is just to provide some indexing to take a cut and relief angle on each tooth of the cutter. The cutter has 12 tooth in all, or teeth, okay? This is the forming tool, okay? In between the two drill rods, that's a button, okay, a drill rod button formed. Well, this is a side view, right? This is what you see on top, okay? The cutter is formed here. Let's say I have, it's made for the dimensions I have here is to make a gear cutter that is 1 1/4 in OD, okay? So these numbers will give you, if I have a 1 1/4 circle here, or blank, cutter blank, and I take this shape out of it, okay, and this, you can't really measure depth, but there has to be a certain depth to the cutter, okay, and this tool is the topping cutter. The portion that would be in between these two discs, which was formed to this pattern, would have this cutter take a sliver on it, okay, and this could be a drill rod shaped into this kind of cutter. You need a pin a 1/4 inch OD, and here's a side view of it. They both need that pin because that pin grabs onto these blocks. Both of them are 3/4 by 1/2 inch. The forming cutter in total length is around 3 inches. From tip of the topping cutter to the bottom of the holder, it's 3 inches. This width here will depend on what size of drill rod you actually put in here, right? If you have 1/2 inch, you can put 3/8 easily in there. It doesn't have to be 5/16. It's just going to be trickier to get a set screw on top of here. So if you look at this from the side, you're going to see this. Well, you need a little bit of material here for a set screw, right? So I don't know if a person makes it fixed, they might be able to put a spring pin through it all, you know, drill rod, you put your piece in there, you drill through it, and then you grind your tool, form it, and heat treat it. And then all you have to do is drive in a spring pin or a tapered pin, if you want to go that route, right? It would permit you to put a larger piece of drill rod, since it's only ½ an inch from here to here. Okay? And this is the side view. Like I said, there's a 5-degree inclination on the platform which holds the button, and the button has a taper to it, right? And I'm guessing these two are on the same plane. So you have 5 degrees, the pin. So you take your pin and you shave 5 degrees on it. And this gives you a positive rake angle, right? Now, the cutter, that's the cutters for the tool. But if you're looking at the gear cutter itself, now the form I was talking to you about just now, okay, that's the middle of your cutter. Okay, well, from here to here, 1 1/4. You need this diameter to be bang on, because that's what's going to be going on your ratcheting system, and you're going to be tightening, clamping a nut down here, okay? And this is 1/4 inch thickness. Now, what I was showing you a few minutes ago was the buttons. Well, imagine there's a button there and a button there taking a cut. Well, then this is the pattern of your involute gear. Okay, so you have a disc 1 1/4 with this pattern all the way around. After that, this is what you see from the side. That's 1 1/4. That's whatever the dimension ends up once you form the gear cutter. And this is 0.5. All right. Now, what you're going to do is you're going to bring that to the drill press. And drill 12 holes. All the way around it, and then you take a slitting saw and you cut out this portion and that portion. So now you've got a cutter with 12 gears, or 12 teeth. Now you use the Eureka tool to put some relief angle on the back of those teeth. Right? And this is, I don't know, maybe 20, I think it's supposed to be 20 thou 230 thou difference between here to the OD and there to nothing, to 0, right? That looks like sort of get the drift, right? This is the cutting edge here. Now normally what you'd see on the bigger mills, there would be a key slot here, and these are probably like 2 1/4 or 3.5 inches or something like that, maybe 4 inches. What they see on the Kern Trekkie, I think, is it Kern Trekkie? I think it's 3 1/4 or 3.5. They're pretty big. But what I'm making here is only for 1 1/4 inch. Now I'm going to kick myself if I've got that 1 1/4 inch wrong, but I know it's just 1 inch and a little bit more, like 1 1/4 inch, or I don't think it's 3/8 anyways. So enough talking. Next we're going to start making some cutters. Not these cutters, the shaping cutters. Since this is pretty much use up what you can, because COVID is starting to ramp up out here, I have some 3/4 by 3/4 stock. I'm going to use this to actually make the cutters, and I got to remove 1/4 of the material on this, so I might grind some down with a grinder, a hand grinder, and the rest I'll machine off of it. If so, I might just set it aside and get me some larger markers in blue and use those. I know you're not supposed to use calipers as a scribe, okay? You normally use a surface plate and use a, oh, what do they call those? For scribes, you can slide on an angle on a surface plate, and you can adjust the level of your scribe. All you do, you put it up against a rule or up against a known value and use it as a scribe. When you're working on I want to put prick punches along this line. I made it 40 thou over, so then I just have a little material to take off. You don't want to start banging on your surface plates, right? You'd want to go on another known flat surface like this wood. You can bang on it, you're not going to destroy it, right? And even so, it's not a costly thing, even if you did. Okay, so all I got to do is grind down to those, and I should be good. Oh yeah, I got plenty of room. like I said, they're not precision thickness. This is going to be in my clamp down in my tool post anyways, right? Not precision. The shape of the cutter is a precise thing though. Actually, a fly cutter for something like this, I think I'm going to make a small fly cutter to, I'd rather grind up a little carbide bit than burn out end mills for no reason. And a fly cutter does a better job really. The only advantage of the end mill is it can plunge and do slots, right? It can face if it has 4 flutes, but it's not the best tool for the purpose. In there pretty good. A 1/2 inch. Well, I finished the cutter or the roughing of the cutter. I still have to put an angle on it, and the cutter holder, you need five or 7 different cutter holders to do the whole gamma from 7 to 135 and rack and pinion. Okay, so this one that I made that was 3/4 of an inch by 1/2 inch wide will only probably be good enough for the 7 to 25 teeth, or it's 7 to 15 teeth cutter reliever. Okay, so here I am here at the lathe, and from the start I am so glad I'm up to this stage of the build. This is the lathe dog that I made before. Then the last step I made was these cutter holders. And this pin, I didn't know how far this ratcheting system would go in and out, right? But this is what keeps this steady. And you put your cutter blank in here. I'm going to try to get it started so you can see how it functions. As you can tell, I don't have an anchor for this, but there's a lot of friction here. I think I can get it going without putting on my backing plate. Okay, there. So I have enough room here for this, and I have really enough room because I have all that room in and out. The only thing that's really happening here is it's going from side to side, right? And that's because the center hole on the end of this was 30 thou off, which means that it's rocking in and out by 30 thou. So that's going to be my relief angle. See? As soon as it gets to this side of it, cut, 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 cut. And for every revolution, I need 12 to get around the cutter once. And this is so cool. I sort of had my doubts when I started this project, but it's working. It's gonna work. Now you have problems getting drill rod to make these blank and these buttons. They want for a 1/2 inch rod, they want $125 for 36 inches of drill rod, which is a ridiculous price. I can only imagine if I bought a 2 1/4 or a 1 1/4, what I'm going to pay for it. If somebody's got any suggestions or suppliers in Canada that are cheaper, let me know. I can't even get 1 inch of drill rod where I live. I have to send out for it somewhere, you know.